Oh, too late. Okay, so we are beginning Unit 3 now. Today is what, the 8th?
Yes.
Today is the 8th. We're beginning Unit 3. We're on lesson number 17. It says apply the product rule of differentiation numerically, graphically, and numeric. Does it say numerically twice? Oh, analytically. Sorry. Okay. And begin. So, now it's like not bright enough. Whoa.
Right. Gotta turn off some more lights.
Okay. Please get to where you can see if you can't see. All right, so here it says rewrite this function as a cubic function and then find the derivative. This is nothing new. You had a question on your test that was similar to this. It was given, you were given a problem that you could have used your calculator on, but if you worked it out by hand, you had to FOIL it out and multiply it through before you took the derivative. So please, everybody, multiply that out and then find the derivative.
This is the answer. Take my belt.
That's funny.
What?
That's funny. It's so funny. He says it and keeps me in line, not the other way around.
Okay, well, you told me I drank coffee when
Wait, what happened?
He told
Who
Ivy.
watches this video?
Recording.
Jump scares.
Recording.
Hi.
Okay, so whenever you're multiplying this out, it's a little bit time consuming. You have to be careful. For me, whenever I am multiplying a binomial and a trinomial, I use the box method because it just keeps me organized.
I don't.
That's fine, whatever works for you. This is what works for me. Okay, multiply this so I get 2x cubed negative 4x squared positive 2x, negative 3x squared positive 6x, negative 3, and then my like terms are on the diagonals, which is nice. So f of x, still f of x. All right, I had some people on the test, your mistakes were that you never did any calculus, and we've talked about that before. When you do a lot of math before you are ready to take the derivative, sometimes you forget to do actually the calculus, and it's painful. Okay, here is f of x. Now we can take the derivative. 6x squared minus 14x plus 8. Everybody okay with that? Okay. It can get a little bit hairy. This is something that was fine and didn't take a lot of time. And when you can use algebra to solve something out, by all means do that. But it can get a little tricky, which is why we're going to use a rule called the product rule today. But just as a review, tell me, what does this equation represent?
The slope of the tangent derivative.
the graph of the derivative line, which is the slope of the tangent line of that.
Okay, all of those were correct, but it's the slope of the tangent line,
Graph.
where?
At x.
At what x? At any x.
That's close to 0.
You ran it, pull it back. Okay, f prime of x is the, you could say function because you can graph it, but it is the slope of the tangent line drawn to the original function f of x at any x value. So I could find the slope of the original cubic function at 0 by saying f prime of 0. I could find the slope of the normal line at 1 by plugging in 1 and then doing what? If I wanted to find... Wait, say that, what's the first word you said? Opposite reciprocal. Yeah, good. I didn't hear that first. Yeah, opposite reciprocal. Good. Okay, so two dudes created calculus at the same time, basically. Those were Isaac Newton and Gottfried Leibniz. In 1673, Leibniz published an article in which he derived what we know today as the product rule of differentiation. Okay, I'm going to show you the formula for this, and then we will talk about different ways that you can write it and to memorize it, because this is just something you have to memorize. All right, notice that here h of x is defined to be the product of two different functions. You see the big old dot representing our product? Okay. Then h, that's an h prime of x. I'm starting my writing neater today. It's just going to start after that h. So h prime of x, one thing also, make sure that always your derivative symbol, your apostrophe, is very obvious. So h prime of x is equal to f of x times g prime of x plus g of x times f prime of x. Okay, that is your rule in function notation. The way that I say this, and so the way I have it memorized is in words. I say the derivative of the product is the first times the derivative of the second plus the second times the derivative of the first. That's how I have it memorized in words. I'm going to write that just as an option. First times the derivative of the second plus second stayed the same times the derivative of the first. And a way that you frequently see this is if h is written as u times v, then h prime of x is u v prime plus v u prime. I can't use that because most of the time my u's and v's look too much alike, but whatever method you want to use to memorize it, it's got to be memorized. This is going to have to be memorized by Wednesday. You will have some kind of quiz on that. You got it?
Let's just not and say we
Got it.
Okay. First times the derivative of the second plus second times the derivative of the first. Okay, I had a very good question just now recording, which is this easier than doing it algebraically? And not always, but sometimes you have to use it. So for this example that we're studying first, either way is fine, and honestly it may be easier to use the algebraic method, but we're going to see some problems where you must use the product rule. It's the only way that it will work. Okay, so let's do the product rule with the same problem that we did up first. So first, what is the first factor and what is the second factor? That's the first thing you have to identify. And again, here in this example, it's a little bit easier, but still go through the process because sometimes it's not as easy. This is my first factor. Maybe I'll call that u. This is my second factor. Maybe I'll call that v. Got it? F prime of x. First stays the same, 2x minus 3, times the derivative of the second. What is the derivative of v? Plus, really be purposeful and mindful when you say that plus, because our other rule that we're going to learn is a minus, and you have to always remember which one is plus and which one is minus. So product is plus. First times the derivative of the second, plus second stays the same, times the derivative of the first, which is what? 2. Do some algebra, simplify that, and make sure that it's equal to what you got in the first part, please. Checks out. First times the derivative of the second plus second times the derivative of the first. For this example that we just did, I think the algebra way is probably faster, but if they get you the same answer, then I don't care which way you do it. Sometimes we're going to have times where we have to use it. So let's move on. Okay, I want to do this one. For time, we're going to do this one, g of x. Let's do both g of x's. We're doing both g of x's, and we're using the product rule. Okay, so again, this g of x here, I would never on my own use the product rule here. Let me see if I can make that clear. Because what could I do more simply?
Distribute
What would I distribute?
the
X to the 1/2, right? Now, you do have to be careful with your exponents, and when you multiply like bases, what do you do to the exponents? You'd add the exponents. What's 2 plus 1/2?
2 and 1/2.
Something that you could take as a, that you could take the derivative of. What's 2.5 as a fraction?
2 and 1/2. 2 and 1/2. 2 and 1 divided by 2.
5/2.
So I do think it'd be easier to distribute through there, but that's depending on how good I am at adding my exponents. Okay, but what we're going to do now is, of course, rewrite because we always do. And then I'm going to multiply using the product rule. First stays the same, times the derivative of the second. What is the derivative of the second term? 2x minus 3, plus the second stays the same, times the derivative of the first. What is the derivative of x to the 1/2? Right, 1/2 x to the negative 1/2. Okay, let's do some algebra. So 2x times x to the 1/2. You're adding x to the 1 and to the 1/2. So 1.5. What's 1.5 as a fraction? 3/2. Bless you. Minus 3x to the 1/2. And this is going to be pretty. I certainly don't mean that. 1/2. What's x to the negative 1/2 times x squared? You have to do 2 minus 1/2. Change that 2 in your head to have a common denominator of 2. How can you write 2? 4/2. So good. What's 4/2 minus 1/2? 3/2. So this is 1/2 x to the 3/2 minus 3/2 x to the 1/2 plus x to the negative 1/2. I've run out of space. Combine what you can. I don't love this problem either. We're going to do one more line of algebra, and let's take this as a lesson that product rule shouldn't be used blindly, all right, if algebra works to simplify, okay? But so we've got 2x to the 3/2, and I've got another x to the 3/2. What is 2 plus 1/2?
5/2.
Thank you. Yes, it is 2.5, but we're going to say 5/2 x to the 3/2. All right, let's see, I got those guys. I've got a 3x to the 1/2 and a negative 3/2 x to the 1/2. So what do I do with the coefficients?
Subtract.
Well, so negative 3 minus 3/2 means so I've got 6/2 minus, or plus 3/2, right? So 9/2, negative 9/2. Do we agree? Does anybody need me to work that out? Okay. So minus 9/2 x to the 1/2, and then plus x to the negative 1/2.
Never do that again.
Well, I kind of want to keep going. The reason I kind of want to keep going is there was a problem similar to this on your take-home quiz that you would have gotten bonus if you could get to a single fraction. And I think one person got it out of 53 kids. So let's see if you can get that to be a single fraction.
Well, who was it?
Not
Obviously no.
you.
It was me.
That was a general you. I don't know. I don't remember who it was.
I'm just-
Okay, so what could we do?
We have to multiply everything by, like x to the 1/2, right? Because you're gonna move that x to the 1/2 on the bottom.
We're going to put x to the 1/2 on the bottom. So you're deciding what is in the numerator and what is in the denominator. This x to the 3/2, is that in the numerator or denominator? Numerator. Put it up there. And then this last fraction I'm going to write as 1 over x to the 1/2. Okay, so what is a common denominator?
X to the
2x to the 1/2. All right? So every denominator has to have a 2 in it. These already have a 2. This one needs a 2, so what do I do?
multiply by 2. Keep top and bottom by 2.
Multiply the top and the bottom of the last fraction by 2. Okay? That'll get the last fraction to have a 2x to the 1/2. What do I do to these fractions?
Multiply by x to the 1/2.
Multiply x to the 1/2 over x to the 1/2. We're still not done with the fun stuff. That's 2x to the 1/2, or the square root of x, in the bottom. Okay? In the numerator, I've got 5x to the 3/2 times x to the 1/2. What do I do there?
You're gonna add x to the
What is 3/2 plus 1/2? Which is 2. 5x squared.
25.
No. X to the 1/2 times x to the 1/2.
9x.
Right, it changes just to an x, so this is minus 9x. And then 1 times 2 is plus 2.
Sweet. And we can simplify that.
That is, I mean, you could rationalize it, but we don't want to. That looks fine.
X cannot equal 0.
Very true. Or a negative number. Okay, now we're going to do the next g of x. So, here, where is the product?
Are you gonna go like GCF?
You can do that. All right, it was suggested that I take out a theta as a GCF, and that is fine. Is that what y'all want to do?
Is that not?
You can do that. It'll work out the same, but I could also just take the derivative of this and treat that as my product. But,
That's too much. Okay.
okay,
Do what?
so what was suggested is maybe, because, and what I'm very happy is that students recognize that there is a GCF of theta, and you could change that if you wanted to theta times 3 plus sine theta. And that's fine and beautiful. Or if you just went ahead and took the derivative, what is the derivative of 3 theta? 3. And then my product would just be this part.
Yeah, I like that better.
So it would be 3 plus, there, I mean, I'm sure, yes, absolutely, you can do this. Take the derivative of each term. So the first term is 3 theta, and the second term is a product. Okay. So now, I have to keep that 3, don't lose that. But this, the first, or if you want to consider this u and v, the theta is my u and sine theta is my v. So if I'm remembering this as uv prime plus vu prime, then what's my u? Oops. Well, look, I've got thetas and x's all over the place. Okay. G of theta is equal to, all right, first stays the same, so theta times, what's the derivative of sine theta?
Cosine.
Cosine theta plus, second stays the same, sine theta, times, what is the derivative of theta?
1.
1.
Oh, I see what you did there.
Okay, so that's 3 plus theta cosine theta plus sine theta.
On a low quiz, I want to say we're going to have to work some of these out.
Yes. Just enough for me to fill in the front page of a loose leaf. It's not going to be long. 3 plus theta cosine theta plus sine theta. Okay. Let's do h of x. H of x. There is no way that algebraically I can rewrite this in any form. Do y'all see that? So we have to use the product rule. And when you're using the product rule, you have to recognize where is the separation of the factors. So I like to draw in a big dot that's going to separate my factors. Where does my dot go?
X and cosine.
Right, between x and cosine x. So then first, or u, is 3x, and second, or v, is cosine x. Please try to take the derivative of h of x. What is the derivative of cosine?
Negatives are.
Okay. All right, I took my derivative correctly, but what I've got written is incorrect, and you need to tell me why.
Parentheses now like the sign.
It's a negative.
That's fine.
So
Yes, the way I have this written,
Yeah.
it looks like 3x minus sine x, right? And that is not what I was trying to do. I was trying to do first times the derivative, so I either need to put parentheses around that, or you can go ahead and move that negative in front. Okay, remember this cosine x times 3. We never keep a number multiplied to the outside or behind a trig function. You're going to bring that in front also. So this is going to simplify to negative 3x sine x plus 3 cosine x. And that is an example where product rule must be used and isn't that bad. I'm not going to ask y'all to do product rule for this guy here because I would never use product rule for this. What would we do?
Just algebra.
We would algebra first and then take the derivative using the product rule. Okay? Please go on to the bottom equation. Find the equation of the tangent line to the graph of f of x at x squared cosine x when x is equal to pi. Okay, you're finding the equation of a tangent line. Something about the take-home quiz that I saw a lot, there was a problem where I asked you for the slope of a tangent line and the slope of a normal line. And at least half of my students found the equation of those lines. Wasted work and sometimes just confused you. So just be careful. In this case, we are looking for the equation of the line, but, you know, don't find it if you're not asked for it. So you need 3 things when you're finding the equation of a tangent line. What are those 3 things?
Y and X is slope.
Okay, so x is pi. What is the function notation for y? What am I going to find?
F of pi.
F of pi, beautiful. F of pi is pi squared times the cosine of pi. All right, what is cosine of pi? So this is pi squared times negative 1, and so we're just going to call that negative pi squared. So that's my y value. Oops, off camera. And then I need to find my slope. How do I do that?
Gotta find the derivative.
Find your derivative. Good. Tell me, what is my function notation for the derivative? I think somebody said it. My function notation for my f prime of pi. Okay, that's what we're looking for next. So first I'm going to find f prime of x, and this is where the new rule comes in. What is the rule? Do you have it memorized yet?
Yeah, the u and then the b prime plus the b and the u prime.
In whatever way works for you to memorize it. And yes, that was correct. All right, so I've got x squared cosine x. I'm going to put my big old dot between the x squared and the cosine x. And I'm not doing that like treating you like you couldn't find it. I'm doing that because I seriously do that to help myself. All right, you are just like me. When we go too quickly, we mess up. So this is something that helps me, and so hopefully it can help you also. So f prime of x first times the derivative of the second. What's the derivative of cosine x? Negative sine x plus second cosine x times the derivative of x squared, which is what? 2x. Clean that up, which means any numbers that are written with our trig functions come in front. So negative x squared sine x plus 2x cosine x. And then now we plug in pi. Okay. What's sine of pi?
0.
What's cosine of pi? All right, so that's 0 minus 2 pi, so f prime of pi is negative 2 pi. And now we're ready for our equation. Y minus what?
Negative.
So y minus negative, so y plus pi squared is equal to, what's my slope?
Negative 5.
Negative 2 pi times x minus pi. Okay. All right, keep going. Next page. The rule isn't that bad. We're just showing you all the different ways that you can see it. Okay, on the next page, you've got two graphs. It says below are the graphs of two functions, f and g of x. Let p of x equal to f of x times g of x, and let r of x equal to x squared times g of x. Use the graphs to answer the questions. Okay. The first, what we're going to do first is work the problem, and then we're going to move up to the graphs when we get to that point. It says if g prime of negative 4 is 2, what is the value of p prime of negative 4? P prime of negative 4 is ultimately what you're looking for, but that means I have to first start with p of x. What is p of x?
F of x times g of x.
Yes, f of x times g of x. Okay, we need to find p prime of x next before we worry about plugging anything in. What is p prime of x?
F times g prime plus g prime times, plus g times f.
All right, so that is your product rule and function notation. And then p prime of 4, what do you think we're going to do?
Find those numbers in the graphs and put them in.
Error 5. Good job. Okay, so we're looking again for p prime of negative 4. So I started with regular p of x. I took the derivative in function notation. Now everywhere there's an x, I'm going to plug in a 4. F of 4 times g prime of 4 plus g of 4 times f prime of 4. Be careful, incredibly careful and neat about where there is a derivative symbol and where there is not a derivative symbol.
It's g prime of negative 4. So wouldn't it be
Negative 4, all of these should be negatives. I'm just trying to show y'all every day what happens when you're not careful and don't go slow. Okay? That's what I'm working for here. Okay, so some of these values are just y values. F of negative 4 is what is the y value on the graph of f when x is negative 4. So go up to f of x. When x is negative 4, what is y? Negative 1. Okay? But then the next value is g prime of negative 4. That means what is the slope of the graph at x is equal to negative 4 on the graph of g. So we got to go to the graph of g. You've got to find x is equal to negative 4, and then you have to find the slope of that. Well, let me find negative 4. Oh,
It's given in the
yeah,
problem.
good. Whew. So, yeah, good, that helps. That would have been an easy thing. That couldn't be estimated, but then luckily we remember, oh, yeah.
it's given?
Thank goodness that's given to us. And so that is 2 plus g of negative 4. That we can get from the graph. What is that? 6. And f prime of negative 4. Okay. Now here, this is where we do need to look at the graph. All right, is everybody with me so far? Please catch up with what I have, and we're looking for this, and I want your attention for that last blank. Okay, for the last part, f prime of negative 4, we go to the graph of f, we go to x is equal to negative 4, and I have to find the slope there. And this is something they don't have to give me, but I can calculate the slope for. How come I can calculate the slope of that?
Straight line.
Because it's a straight line, right, because it's a line. And that you will be expected to do. You can look at a graph and you can immediately determine slopes. If it was like at a relative max or min, you would know the slope was 0. Or of a line, because you can just calculate rise over run. What is my slope there? Just negative 1. Okay, but yeah, you wouldn't be asked to estimate or to approximate the slope at a curve, if it was something that was looking for an accurate answer. Okay, and now what's that? Negative 2 minus 6, so negative 8. So p prime of negative 4 is equal to negative 8. Okay. Next one says, if r prime of negative 2 is 20, all right, I'm not going to forget this time, that is given to us, so that we'll need that. What is the value of g prime of negative 2? Well, you need to start with what you know. We don't have an equation for g of x, so it's not something I can take the derivative of. But what do I have an equation for?
R of X.
Yeah, I can start with r of x. R of x was given to me up top as x squared times g of x. All right, now I've got derivative values, so I want to take the derivative function. Please take the derivative of r of x.
Take the derivative of it, or wouldn't we set it up like the product?
Yep, take the derivative as a product rule.
Okay.
So the derivative of r, and then it's the product of x squared and g of x. Okay. You are given r prime of negative 2. So when I plug in negative 2, I'm going to have a value for r prime of negative 2. I am looking for g prime of negative 2. So after I plug in negative 2, I should be able to find, either because the value is given or find from the table, every value except for g prime of x. So plug in negative 2 for every single x. Yes. And so either values are just numerical, we can just figure them out, or we're given to them, or we will use the graph. But my only unknown should then be the derivative of g at negative 2. Okay, I'm at the point where I have to find g of negative 2. How do I do that?
Algebra.
Go to the g graph.
Oh wait, I was saying something else.
Oh, g of negative 2 is negative 3. Here, be careful, my dots and my negative signs really maybe need to be more clear. So I've got 20 is equal to 4 times g prime of negative 2 plus negative 3 times negative 4. Any questions so far? So this is just an equation, and your only unknown is g prime of negative 2, so we're just solving that equation for that. So I get 20 is equal to 4 times g prime of negative 2, and then plus negative 3 times negative 4 means plus 12. I'm going to subtract 12 from both sides and get 8 is equal to 4 times g prime of negative 2. And then what do I do?
Divide by 4.
Divide by 4 on both sides. 2 is equal to g prime of negative 2.
I didn't even. That's cool. cool. I used to look at it as like a variable.
All right, what is your product rule? What is it? Olivia, what's your product rule? No. Hmm? I was saying no to Ryan, not you.
Is it f of x times u?
Mm-mm.
Then uv prime times v prime.
Melanie, what's the product rule?
uv prime plus v prime.
Yep.
Can I do this multiple test?
Yes, and then when you come back, tell me the product rule. Yep. Okay, next page. All right, here is a throwback question. Well, let's look at the format of this question. Okay, this lesson, all you've learned is one single rule, right? One formula. But now we're giving you in all of these different ways that you could be asked to use this information. So given graphs, using function notation in the example before. Here is given a table of values. I don't think we've used a table of values like this before, but they come up a lot. So let's look at what we've got here. We've got a column of x's, so 4, 3, negative 1. And then you've got different function values. I've got all the function values for f of x, g of x, f prime of x, and g prime of x. Okay, everybody see what you're looking at? I love these because there's not much, I guess, basic calculations going through. It's a lot of just, I don't know, not so much arithmetic and more just calculus. So the first question says estimate the value of f prime of 3.5. This question we learned how to do in Unit 2. It was not on your test, I don't think, but this is AP Calculus. Everything could be on any test, always. Okay? No pressure. So, estimate the value of f prime of 3.5. When we saw the word estimate, what did that tell us to do?
Use the tangent line.
No, you're thinking the right thing, but saying the wrong word.
Like using the equation.
But y'all, I'm given a table of values.
Look to the right and left of that.
You should use a number line, huh?
We're going to look to the right and left of where 3.5 would be on this table. So to estimate f prime of 3.5, you need to, what we're going to do, and this is what I was, is we're going to use the slope of the secant line. Do y'all remember that? 2 points. Yeah, you're using 2 points on the original function f. So we're going to look in this first column of f values. And x is equal to 3.5 would be between 3 and 4. Do you agree?
I agree.
So here I'm going to use f of 4 minus f of 3 over 4 minus 3.
Wait, can you move your-
Yep, sorry. I wish I could move this little box, but
So,
I don't think.
why can't I just go look at f prime and look between like that on the chart? Or I have to go right-
Because you could have, I mean, what would you pick between there?
Like just like whatever.
Between 2 and negative 4, what would you pick? That's 6 values.
Yeah. But what if they give you a chart and it's more, and it's closer? Like, the
This is
values
the way you do it. If you are calculating, if you're estimating a derivative, you always are going to use the secant line.
I did it a different way, but I got it right, but it might not work all the time. So I did what he did, and so, negative 4 on the number line and 2 on the number line. The exact middle between them is negative 1, which I got for the answer.
That will not, I mean, well, also you aren't always given the derivatives. Take that back.
I'll take it back.
No, I'll give you another time.
You must, and if this is a free response question, you also have to show your work.
Yeah.
That's
So
not
just
going
go
to.
over 3, then over 3, and then
That's
No.
what I was showing you.
No.
I thought you did food.
Oh, and one thing I should also do is make this an approximate. F of 4 is 1, f of 3 is negative 2, 4 minus 3 is 1, so that's 1 plus positive 2 over 1.
Like the answers that matter.
Wait. messed up, my bad. My bad.
You're right, bro. I'm so happy.
I am really happy about
I'm gonna have
that.
to take that back, man.
I
How do you take that off?
Because I saw the answer that I wanted, and so I just got the answer.
Okay. So when you are told to estimate a derivative, you're using the slope formula of the secant line of the original function. This is really important. Notice that I'm estimating a derivative, and I'm using plane F. Okay.
What secant function?
The secant line. Secant line, remember from day one of Unit 2, secant line goes through 2 points, and
Oh, yeah,
as
okay.
those points get together, that becomes the tangent
Yeah,
line.
I see.
Okay. All right. I want you to try the next one on your own. Let's see. I'm going to freeze the screen, and I'll put the answer up in a minute. I don't know what that's going to look like on the recording. Recording, I think you can still see my hand moving. What do y'all think the derivative of 2f of x is? It's just it's a coefficient. So the derivative of 2 times f of x, it's like if I asked you what's the derivative of 2 sine x. You would keep the 2 there, take the derivative of sine, and then put the 2 back.
So
So-
it's 2f prime of x?
So it's 2f prime of x. What is the derivative of 4g of x? 4g prime of x.
I'm talking about the answers.
Stop. That's your derivative. Look on the board to check yours. Okay, and now you're plugging in 4 everywhere there is an x.
Damn, that's so wrong.
So
I did like the product, I did like the 2.
That's what I was trying to do.
So in this lesson, it's called product rule, but look, this is new to you also. This is also something you haven't seen before. So in using a table, what do we do? So it's pulling up all these other things so in the first one, we were reviewing how to estimate derivatives. Here we're learning, we're reviewing derivatives with coefficient, the coefficient rule. Okay? And now I use the table. This is why I like these. Look, you're done with math. You just have to carefully, you got a lot of values there, so you have to be careful. 2 times, what is f prime of 4? 2. Minus 4 times, what is g prime of 4? Negative 3. 4 plus 12, so that is 16. Okay, I want you to try the next couple on your own, and I'll put up the answers.
Is this one the product?
You tell me, is there a product there? Well, is it being added, subtracted, multiplied, and divided? What's happening there?
Multiply.
It's being multiplied. This is
That
the
is a
product.
product.
F of x times g of x, yes.
So smart.
Or would be multiplied by the whole thing. I think it's multiplied by that's just how order of operations works. Like, it gives you parentheses on f of x and g of x. Yeah, so you're just multiplying it and then you're 2 times that. It'd be like 2 times 4 times 3. 2 times 4 times 3, right? So it'd be 3. The answer is negative 16. From where? 'Cause I got 0. What's happening? Okay, anyone else do Claire, what did you do? Wow. So like, I got negative 2. Now it's negative 2 times 2.
Because again, that's why I can't use them, is because my.
That was what? Wait, how did you go on what else did you? Minus 2 times negative 4 times negative 3. No matter what we do. Okay, look, Claire, did you do this? I got 3. They just end up canceling. Did you get negative 2 times negative 2? Okay, well, you just simplify that. You got 3.
We had finally got it adjusted. It was 1601, 16.1.
Oh, no, okay, I got negative 6.
Already did, and he said it for you.
That's just the type of guy he is.
Yeah, he's like, I'll let you work it, like someone else that in like.
It was here, you said it.
And they're just meters.
I know this is a
Wait,
I
why did
got
I?
0.44 in a second.
If you have a beautiful person, it just makes it a little bit harder, whatever.
Is that how much like it's been on 16.1 or negative 16?
Take a 32.
That is
I have 8 positive. For this, it was athletics. You gotta make sure. Yeah, I'm trying to break 16. I was so mad 'cause I was like less than a second from breaking 16. Like, that was that was the first time.
Everyone's doing negative.
I think your dad had it. It is. That's
No,
okay.
because these are multiplied together.
your dad has one.
The high jump, right?
And so now you're doing negative 2 x g of x plus g of x times negative 2f.
It's 6 and 8.
Yeah.
He said something like 15. Like my dad was
Because
16,
these
I beat my
are,
that was 611.
like this isn't, if this was multiplied by each other, then you would divide. This isn't multiplied by each other, this is just, like you wouldn't count that as being multiplied
For
together.
some reason.
Yeah. Kids are getting shorter. I mean, there's a really short person that jumps on the middle. You just have to do really good jump from spring up, bro. But yeah. It's like from cold water or something like that.
Good afternoon, everyone. We want to say congratulations to our cross-country team for an outstanding finish in the Catholic High Invitational this weekend. Boys finished 10th and girls 8th out of 45 teams. 12 people ran personal best times this weekend, and many more had season best times. Nick Broderick placed 7th overall in the boys race and broke the 3-mile school record running 16 minutes flat. Kylie Zeller placed 12th overall in the girls race and broke her own record with a time of 19:21. Congratulations to all of our cross-country runners. Tomorrow morning, don't forget to pick up your breakfast on the way to class. It's chocolate-filled crescent rolls, and everyone have a great afternoon.
I ran a 5:11 for the first mile.
Oh my god, I don't think I've ever read a mile under like 7 minutes.
You're up like 10 miles. But yeah, he's
I
like
mean,
best in the
drink
state.
your coffee wrong.
I know, that's what you told me.
She stirs caramel macchiato.
I don't want to drink plain milk.
He's like a whole other.
You stirred macchiato?
Are
you not?
7 mistakes.
No.
No, it's the whole point.
It's a guy named
As a
macchiato.
macchiato.
It is.
It's a margarita latte.
It's literally cheaper to do as a latte.
Okay, but the thing
I don't know, I'm not a white girl, so I'm
plain
going
milk.
shut up.
Then just order a latte.
That's like
Yeah,
Kylie's
but-
because she's not a
I
man.
don't know about that.
Can somebody go work out the last square for me? I haven't gotten to yet. Can y'all do that on the desk?
What's the point of that?
I got it. What is the answer?
Negative
What is
16.
the answer?
The answer on the bottom left,
What is the
I don't
answer?
remember what the answer is.
God.
That sounds really good.
What time is it?
It's time for free to go write that on the board.
Excuse me for our afternoon bus announcements. We have 2 bus breakdowns today. Ms. Robbie Shaman, bus
Your
424,
homework is,
and Ms.
You
Anna
want me to stop the
Gibson,
recording?
bus 374.
yeah, stop the recording, please.
On Ms. Robbie's bus,
Ivy, what's homework?
if you live on Fort Street at Petersburg, you will get to be riding on Park Road today.